Hi there. In today's video, we will be talking about M1 Chapter 6 Momentum and Impulse. So, momentum is the product of mass and velocity that you all know. But momentum is a vector quantity. So, for example, if you have this ball of mass 2 kg moving rightward at a speed of 10 meter per second, it will have a momentum of 20 kg meter per second. Simply the mass times the velocity. However, if you have a ball with the same mass but the speed is now 10 meter per second in the left direction, now what is going to happen? The momentum will still have a magnitude of 20 kg meter per second, but this time it will be in the opposite direction. But we know that momentum is a vector quantity. So how can we signify the direction of our momentum in our answer? In my example, I have taken the right direction as positive. So this velocity will be taken as positive 10 meter per second, and this velocity will be taken as negative 10 meter per second. So if you multiply positive 2 with positive 10, you get positive 20 kg meter per second. Positive 2 with negative 10 minus 20 kg meter per second. So if somebody asks you, what is your momentum? You're going to say the momentum is 20 kg meter per second towards the right. How did you understand that the momentum is towards the right? Because of this positive sign. And if this is the answer, the momentum will be 20 in the left direction. Why left? Because the sign is negative. And finally, you have to say that in this math, we have taken the right direction as positive. So usually such long answers are not necessary. All you have to say is that the momentum is positive 20 meter per second, which means magnitude is 20 kg meter per second, and the direction is towards the right. But you have to improvise your direction from math to math. The direction will not always be towards the right. It might be upward or downward. You have to improvise in that way. But the bottom line is that you have to take some direction as positive and the opposite direction as negative. And if a momentum comes positive or negative, then you can identify the direction of that momentum accordingly. The same goes for velocity. If your velocity turns out to be positive, then you can say that yes, the velocity is 2 meter per second in the right direction, or minus 2, that the velocity is 2 meter per second in the left direction. So we will do math using this concept, so don't worry if you didn't understand the last two sentences. So using this knowledge, you should be able to understand example number 1 in page number 102. So I'm not going to do that right now. What I'm going to do is I'm going to explain the relationship between momentum, impulse, and the change in momentum. So there is something called an impulse. So impulse can be expressed in two ways. Okay, so the impulse, force into time, force and how long that force is acting. This is the force and this is how long that force has been acting for. This is called impulse. However, this Ft can be expressed by another formula. This Ft can be expressed by the formula mv minus mu. So what are all these short forms? This force is force. This time is the time for which the force is acting. For example, if you're pushing a box for 2 seconds at a force of 10 newtons, then F is 10 and T will be 2 seconds. And m is the mass of your box, v will be the final velocity of your box, u will be the initial velocity of your box. So if you have a box of 2 kg, and you have pushed this box at a force of 10 newtons. Perhaps let's get rid of the force. You have pushed this box. Initially the box had a velocity of 0, it was at rest, but after you pushed it, the box gained a velocity of perhaps 2 meter per second. So what is the change in momentum? The change in momentum is mv, v is 2, mv minus mu. So 2 into 2 minus 2 into 0. M is 2, V is 2, U is 0. So that should give you a change in momentum of 4 kg meter per second. So what will be the impulse? The impulse is equal to 4 meter per second, because impulse is equal to the change in momentum. Okay. So impulse is equal to 4 meter per second. From there, if the question asks you what will be the force, if the box has been pushed for 3 seconds. Okay. So now you know that the impulse is equal to 4 kg meter per second. An impulse is equal to force into time, that is 4. And force, we have to find out. It has been said that the time is 3. It was being pushed for 3 seconds. So our force is equal to 4 by 3 newtons. So I haven't written the units here because all the units were in their SI units, meter per second, kg, newtons. So I haven't written the units, but you should write your units in your answers, and you should take care of the units particularly. So this was a basic example that I made regarding the change in momentum, impulse formula, and how to find the unknown, either F or T. So we will do examples regarding this formula, so nothing to worry. Now let us look at example number 3 on page number 103. So this is page number 103. Example number 3. This is not exercise, this is example number 3. So don't see the diagram, because the diagram was drawn in the solution. We will try to extract the diagram from the solution, from the question. A ball of mass 0.2 kg hits a fixed vertical wall at right angle with a speed. The ball rebounds with a speed this much. Find the magnitude of the impulse exerted on the wall by the ball. Fine. So we have a wall, and a ball was coming towards the wall at this velocity. This is before collision. Oh, by the way, for momentum and impulse maths, if there is a collision or an explosion, you have to draw two diagrams, one before the collision and one after the collision. So this is before the collision, and here I will draw after the collision. Here we have the same wall. The ball will now bounce back. This is the basic scenario of what's happening. So now you start to fill up the information. The ball has a mass of 0.2 kg. So the mass is 0.2. The mass is 0.2. I haven't written the unit because it is SI unit kg. It was incoming at a speed of 3.5, and it went out at a speed of 2.5, and we have to find out the impulse, okay, the magnitude of the impulse. Now we know that impulse is equal to the change in momentum, okay. Impulse is basically force into time, but we don't know the force, we don't know time, but we know that force into time can be written as mv minus mu. If you want the derivation of this mv minus mu, how ft is equal to mv minus mu, you should see page number 102 in your M1 book. Basically this is derived from Newton's second law of motion. So we don't know ft, but we do know our mass and our velocities before and after the collisions. So this is what we're going to use. M is the mass. So our m is 2 kg. So m is 0.2 kg. Our v, okay. So this is where things get interesting. We were incoming at a velocity of 3.5, okay. Now for this math, I'm going to take my right direction as positive. So since the velocity here was towards the right, I'm going to take my u as 3.5, positive 3.5, because the velocity was towards the right, and I have taken my right direction as positive. After the collision, the velocity, that is the final velocity, is 2.5, but this time the velocity is towards the left, and since I've taken the right as positive, the left will be negative. So my final velocity will be minus 2.5. So v will be minus 2.5. Minus, this is the minus of the formula. Once again, my m, that is 0.2, u will be plus 3.5. So before putting these values in the formula, just after drawing the diagram, it is better to identify your m, u, and v, and maybe list them down somewhere on the left, but it is just as okay if you write the things down in your diagram itself. So after the calculations, your impulse will be equal to 1.2, negative 1.2. So this negative 1.2, what are they asking? The magnitude of the impulse, okay. So here is where it gets more interesting, because by the way, the impulse has a unit of Newton second, because impulse is equal to force into time, force Newton, time seconds. Negative 1.2. This is our answer, right? The question asks for the magnitude of the impulse. So the magnitude, in magnitude we ignore the sign. So our magnitude of impulse will be, magnitude means a modulus, magnitude of impulse will be 1.2 Newton second. That is our answer, okay. We gain full marks for this question up to this, no problem. But I want to discuss something with you. What if the question asked, what is the magnitude and direction of the impulse? The magnitude is 1.2, that is okay. But what if the question asked for the direction? For the direction, what you're going to say is, your sign is minus. You had taken the right direction as positive, so automatically the left direction is negative. The sign is negative, which means the impulse was exerted on the ball. The impulse was exerted on the ball in the negative direction, in the left direction, okay. So the wall exerted an impulse on the ball on the left direction, and the ball exerted an impulse on the wall in the right direction, according to Newton's third law of motion. This should be intuitive if you think carefully about this situation, okay. Now we're going to come to our main formula, the formula which will be used mostly for our chapter. It is also present in physics. m1 u1 plus m2 u2, m1 v1 plus m2 v2. So this is a situation where we have perhaps two balls coming towards one another, and they collide, and after the collision they are going away from one another. Okay, so the mass of the first ball is m1, the mass of the second ball is m2. m1, m2, the masses don't change. However, before the collision, the velocities are the initial velocities, so the velocities will be u. The velocity of the first ball will be u1, second ball initial velocity u2. After velocity, the final velocity we represent by v usually. So v, final velocity of the first ball v1, of the second ball v2. So depending on the direction at which the balls are moving, we will assign our u1 and u2 the respective signs. For example, here the ball, in my example, this is just an example, here my ball is moving towards the right, so u1 will be positive, u2 will be negative because it is towards the left. By convention, I always take the right direction as positive. So u1 will be positive, u2 will be negative, v1 will be negative, v2 will be positive. So in this way, you list your u1, u2, v1, v2, m1 and m2 and simply put them down in your equation and you will get your answers. So before inputting these values, instead of just watching, instead of just seeing the question and manually inputting the values, draw this diagram before and after collision and write down your u1, u2, v1, v2, m1, m2 on your diagram. Therefore, you can copy those values to your equation. Okay. That being said, we can now move on to our example number 6, page number 106. So we will be doing page number 106, example number 6. So once again, here the diagram, the solution has a diagram, but we will not draw from the solution, we will do our own math. So ignore the solution. Two particles P and Q of masses 8 kg, 2 kg respectively are connected by a light inextensible string. So this could be a little bit difficult. Okay, whatever, it is similar to collision. Two particles P and Q of masses 8 kg and 2 kg respectively are connected by a light inextensible string. The particles are at rest on a smooth horizontal plane with a string slag. Particle P is projected directly away from Q with a speed of 4 meters per second. So the initial situation that we have, that is before the collision, B, before the collision, we have two particles. The one particle is P, the other particle is Q. They were connected by a string which was slag. Slack means the string is not taut, there is no tension in the string. And particle P is projected directly away from Q with a speed of 4 meters per second. So in the solution, they have used the right ball as P. So let me do the same so that it is not confusing to you guys. Okay, P, and here we have Q. So this particle P was projected from Q with a velocity of 4 meters per second. So let us take our Q as m1, our P as m2, and therefore this will be u1 and our P will be u2. Okay, so our Q was at rest, so u1 will be 0, u2 will be 4 because P was thrown away from Q at a velocity of 4 meters per second, and m1, P and Q 2 and 8 kg respectively. So Q1 is 8 and P is 2 kg. So this is the situation before the collision, m1, m2, u1, u2. Similarly, after the collision we will have another diagram. After the collision you can intuitively understand what's going to happen. The string will get taut, both P and Q will be moving at the same velocity. Therefore we don't have to draw different arrows, we just can draw one single arrow to represent the combined velocity V. You don't have to put V1 or V2, they both have the same velocity, V. So this velocity we don't know, but the masses will remain the same. This is our P, this is our Q, m1 and m2, 8 and 2 respectively. This is 8 and this is 2 kg, m1, m2. Now find the common speed of the particles after the string goes taut. So our formula m1 u1 plus m2 u2 will be changed just a little bit. So a better way to understand the formula, the total momentum before the collision is equal to the total momentum after the collision. So total momentum before collision is equal to the total momentum after. So before the collision we had two separate bodies with two separate velocities, so there will be m1 u1, this will be the momentum of the first particle, that is q, and m2 u2, that is the momentum of the second particle. After the collision, what is happening, we have m1 and we have the particle m1 is moving at a velocity v, so m1v plus m2, this second particle is also moving at a velocity of v, m2v. So now what you want to do is you want to input the values of m1, m2, u1, u2. So m1 is 8, u1 is 0, m2 is 2, v2 is 4. m1 is once again 8, we don't know, m2 is 2, and v we don't know. So v is the only unknown in the equation. And let me match okay, there was a little bit of a mistake here. The mass of particle p was 8 and the mass of particle q was 2. So q is 2, p is 8. Q is 2, m1, and p is 8. Okay, so this will be 2 and this will be 8. So 8 into 4 is 32 divided by this. So our velocity will be 3.2. So the combined velocity after the collision will be positive 3.2. So our velocity turned out to be positive. Therefore, both the particles are moving towards the right. And the magnitude of the impulse transmitted through the string when it goes taut. So impulse is equal to mv minus mu. So you have to consider any one particle here, either particle q or particle p. So let me consider particle q. For particle q, the mass is 2, its initial velocity was 0, its final velocity was v, which is positive 3.2. So our m is 2, our v is 3.2, minus our m is 2, our u was 0. So 6.4. This should be our impulse. Don't forget to put the unit. This is positive 6.4. Therefore, the impulse exerted on the particle q was towards the right. But this is not what they asked for. They just asked for the magnitude. So the magnitude of the impulse modulus, will be 6.4. If you don't understand this modulus symbol, just put magnitude is equal to 6.4 Newton second. That should be your final answer. And now we have an interesting question, example number 7, where we have to work with an impulse to find both the unknown velocities after the collision. So we have two particles A and B of masses 2 and 4. They're moving towards each other in opposite directions along the same straight line on a smooth horizontal surface. The particles collide. Before the collision, the speeds of A and B are this much. Given that the magnitude of the impulse was this, find the velocity of A and B after the collision. Okay, so we have two particles moving towards one another. So once again, this is page number 106, example number 7. So before the collision and after the collision, we have to draw two diagrams. Before collision, the two particles are moving towards one another, and after the collision, we don't know what is going to happen, but let us assume that both the particles are moving in the same direction. Let us assume. So here we have two particles A and B. This is particle A, this is particle B. Once again, this is particle A, this is particle B. So instead of putting M1 and M2, let us put MA and MB. That will make our working a little bit simpler. Okay. So MA, as the question says, is 2 kg. MB, the mass of particle B, is 4. 2, 4. So they were coming towards one another at velocities of 3 and 2 respectively. So A had a velocity of 3, B had a velocity of 2. And after the collision, we don't know the velocities, so let us put VA and VB. This is the entire scenario. Now, we know MA and MB. Let us list UA and UB. So UA is the initial velocity of A, that is 3. And what is the direction? It is towards the right. And we usually take the right direction as positive. So positive 3 meter per second. B has a velocity of 2 before the collision, and it was towards the left, and automatically the sign will be negative because we had taken the right direction as positive. And VA, VB, we don't know. Now, one more thing that we know is that the impulse exerted was 7. So we are going to apply the impulse formula for two particles, particle A and particle B. Okay. So for particle A, impulse is equal to mv minus mu. For particle B also, impulse is equal to mv minus mu. So for particle A, the mass of particle A was 2 kg, so m was 2 kg. The final velocity of particle A was va, that we don't know. Its mass was once again 2 kg, and the initial velocity of particle A was positive 3, so positive 3. And the impulse had a magnitude of 7, so the impulse had a magnitude of 7. Okay, fine. So one thing to keep in mind, since A and B are colliding, B pushes A towards the left, therefore the impulse exerted on A due to the collision is negative. Why negative? Because B pushes A, B exerts the impulse on A in the left direction. Okay, imagine that you are A, B pushes you to the left, B provides an impulse on you to the left. So this leftward impulse will have a negative sign because impulse is also a vector quantity, and it will have a negative sign because P just pushed A to the left. From there we can understand that A will have a final velocity of minus 0.5. Okay. So I assumed that A was moving to the right, but here the velocity turned out to be negative. Therefore the actual velocity of A is towards the left, and it has a velocity of 0.5 meter per second. Similarly, I can find the final velocity of B. So the impulse exerted on B was 7, positive 7, because A pushed B to the right, and the rightward impulse is a positive 7 because right direction has been taken as positive in our math. The mass of B was 4, and the final velocity of B was Vb, that is we don't know. And once again mass is 4, and the initial velocity of B was negative 2. From there we can understand that the final velocity of B will be 0.25, positive 0.25. Therefore, we had assumed that B moves towards the right, and here our answer turned out to be positive. Therefore, our assumed direction of B, the final velocity of B, was correct. Therefore, B does move towards the right after the collision, and the velocity after the collision is 0.25 meter per second. So that should be your example number 7. We are now going to do two maths from chapter review number 6. This is on page number 109, chapter review number 6, and we are doing number 2. Excuse me. A pile driver of mass 1000 kg drives a pile of mass 200 kg vertically into the ground. Okay. The driver falls freely a vertical distance of 10 meters before hitting the pile. Immediately after the driver impacts with the pile, it can be assumed that they both move with the same velocity. By modeling the pile and the driver as particles, find the speed of the driver immediately before it hits the pile. So we have a driver falling towards the pile, and the driver falls through a distance of 10 meters. And from there, the question asks us to find the velocity of the driver as it hits the pile. So the driver here we have, and it falls through a distance of 10 meters. From here to here we have a distance of 10 meters. Initially it was at rest. Okay. Initially it was at rest, and we have to find the velocity as it hits the pile after falling a distance of 10 meters. So our S is 10. B we have to find out. But this is basically an SOVAT question. We know the S. Our S is 10. Our U is 0. Our V we have to find out. And our A is 9.8. Okay, so we have taken the downward direction as positive in our SOVAT because everything is downward. The displacement is downward. The acceleration due to gravity is also downward. So we have taken the downward direction as positive. Therefore, our displacement is positive 10. Our acceleration due to gravity, which is downward, is also positive 9.8. So from here we understand that we have to use a formula that includes S, U, V, and A. That formula is V square is equal to U square plus 2AS. Our V is something that we have to find out. Our U was 0, so let us omit that from the equation. So 2A, that was 9.8, into S, that is 10. From there we can find our final velocity to be 14 meters per second. So this is the velocity with which the driver impacts the pile. Now, the common speed of the pile and the driver immediately after the impact. So now we know the velocity with which the driver hits the pile. We have to find their combined velocity after the collision. So this looks like the math that we did in example number 6. So this is a collision math. So we have to apply the law of conservation of momentum. So let us draw the diagrams before and after the collision. So before the collision, let me now model the driver as a circle. Before the collision, we had our M1, our driver, and our M2, the pile. We have our M1, that is 1000 kg, and our M2 as 200 kg. So our M1 was moving downwards at a velocity of 14, and our M2 was stationary. Therefore, our U1 is 14. For this math, we have taken the downward direction as positive. Therefore, our U1 will be positive 14 because the velocity 14 was downwards, and our U2 will be 0 because our pile was stationary basically. So after the collision, the question says that they both move with the same velocity downwards. So the combined mass, instead of considering them as separate bodies, in this example, let us combine them as just a single mass. You could have applied the same concept in example number 6. You could just assume them, consider them as one combined big mass. So this combined mass of the pile and the driver has a total mass of 1200 kg, and they have a combined velocity of v. Now, applying the law of conservation of momentum, the total momentum before collision should be equal to total momentum after collision. So before collision, we had two bodies. We had M1 and its velocity. We had M2 and we have its initial velocity. After the collision, we have one single body of a big mass M, and we have the combined velocity v. M1, as our diagram says, is 1000. Our U1 is 14. Our M2 is 200, but our U2 is 0. Our combined big M after the collision is 1200, and our V we have to find out. Using this equation, we can find our combined velocity after the collision to be 35 by 3 meters per second. This is the velocity with which they both are going towards the ground after the collision. So this is what's going on. The driver was falling to a distance of 10 meters. It attains a velocity of 14. It hits the pile, and they both go at a final velocity of 35 by 3 meter per second. So this is what's going on. So please take a note. I'm going to erase this part for doing number C and D. Okay. The ground provides a constant resistance to motion of the pile driver of magnitude 120,000. It was a constant resistance to motion of the pile driver of magnitude 120,000. Find the distance that the pile is driven into the ground before coming to rest. Okay. So now we have a situation where we have this pile driver combined body of mass 1200, as we saw. We have this entire system. This is part C. We have this entire system moving at a velocity of 35 by 3 downwards. Now it will move a certain distance. Since this entire body was being pushed inside the ground, after moving a certain distance, this body will come to rest. Okay. So after a certain distance, this entire body will come to rest. We want to know how far that is. Now, the resistance to motion, the resistance from the ground was 1, 2, 0, 0, 0, 0. Okay, and the resistance is definitely acting upwards since the bodies are moving downwards. If you push the ground downwards, the ground will provide a resistance upward, that is opposite to your direction of motion. Simple. Now we are going to apply the formula F is equal to ma, Newton's second law of motion. Okay, so for this situation, we have to draw a free body force diagram of our combined body. So our combined body has a downward force of their weight and an upward force that the earth is providing, the ground is providing, that has a magnitude of 1, 2, 0, 0, 0, 0. Okay, and We have taken the downward direction as positive in our math. So our 1200G, our weight will be positive and our resistance to motion will be negative. The combined mass of the system is 1200 and the acceleration is something that we have to find out. Okay, so from here we can find our acceleration. So our acceleration has a value of minus 90.2 meter per second square, and this is definitely supposed to be negative because this entire thing should be decelerating. Therefore, the acceleration has a negative sign. Now we know the acceleration, we know the final velocity, that is 0, we know the initial velocity, that was 35 by 3. We want to know how far it goes, that is s. Which formula is concerned with a, v, u and s? Once again, v square is equal to u square plus 2as. So our v is 0, our u is 35 by 3 whole square, plus our 2, our acceleration is minus 90.2, and our displacement is something that we have to find out. From here we can find that our displacement is 0.75 meters. Okay, part C is done. As for the final part of the question, comment on this model in relation to the motion of the pilot and the driver immediately after the impact. Okay, so we have to comment on the model. The entire model was that the driver hits the pile, they stick together and they enter the ground after their collision. But we have to comment on this model based on that particular situation when the driver hits the pilot and they start to move as a single body. So ask yourself, if there is a nail here, and if you hit this nail with a hammer, will the hammer and nail move as a single body? They might, but if you have ever used a hammer, you will understand that the hammer lifts or bounces back from the nail for a very brief period of time. Okay, so the same thing will happen for this driver and pile model. The driver is supposed to bounce back from the pile for a very short amount of time. So this model is not completely accurate, but that time for which the driver bounces back is so short that we can assume that the driver and the pile stick together as a single body throughout their descent into the ground. So this entire answer is elaborated clearly in our answer, but this is the explanation of what's going on. So this was number 2 of chapter video number 6. For our last math, we will be doing page number 110, number 6. This is page number 110, math number 6. So, particle P of mass this moving towards us, moving along a straight horizontal line with the speed. Another particle moving in opposite direction along the same straight line. The particles collide immediately after the collision. The direction of motion of P is reversed, and its speed is 2.5. Okay, fine. So we have a situation where two particles collide. We know what to do. We have to draw a diagram before the collision, and we have to draw a diagram after the collision. So before the collision, we have two particles, P and Q. Here we have particle P, particle Q. So they are moving towards one another. So this is MP and this is MQ. The initial velocity of UP and this is the initial velocity of Q, that is UQ, right? So P has an initial velocity of 3 meter per second. So since P here is moving towards the right and we usually take the right direction as positive, the velocity of P is 3 and it is towards the right, so the velocity is a positive 3. Q on the other hand has a velocity of 4 meter per second on the opposite direction, in the opposite direction. So the velocity is 4, but it is towards the left, and since the positive direction is right, the left direction should be automatically negative. And MP has been taken as 1.5 and MQ has been taken as 2.5 in our question. So this is the situation before the collision. After the collision, what is going to happen? We have a particle P and Q. The masses are the same, so I'm not writing them again. The direction of motion of P is reversed. Okay, so P was moving towards the right before the collision. After the collision, its direction will be reversed, the question says. So VP and VQ, we can assume that VQ Q moves towards the right, we can assume. So VQ here, right. So this VP will be negative because we assume that we don't assume, the question says that P reverses its direction. So the velocity will be towards the left, and since this is towards the left, therefore this velocity will be negative because we have taken the right direction as positive. So this is all the information that we have. We have another information that the final velocity of the particle P in that direction is 2.5. Therefore Vp is equal to minus 2.5. Why minus? Because this velocity is towards the left. Applying the law of conservation of momentum, the total momentum before the collision should be equal to the total momentum after the collision. Before the collision, we had two bodies, MP, UP. This is the momentum of P before collision. We have MQ, UQ, momentum of Q before the collision. We have MP, VP, MQ, VQ, momentum of P and Q after the collision respectively. So MP is 1.5 kg. I'm just writing the things down from my diagram. This is the advantage of drawing a diagram. Positive 3, MQ is 2.5, UQ is minus 4, MP is the same, that is 1.5. And our VP is minus 2.5, our MQ is 2.5, and our VQ, we don't know VQ, but we had assumed that VQ will be towards the right. Therefore, we had taken the sign of VQ as positive. So this is a positive VQ. So VQ is only unknown in the equation, and from there we can find the speed of Q immediately after the impact to be 0.7. Okay. So whether this will be positive or negative, we have to find out. 0.5 into 3 minus 4 into 0.5. Okay. So the velocity of Q will be negative 0.5 meter per second. Okay. This negative sign signifies that the direction of the Q we had assumed after the collision is wrong. We had assumed that Q will be moving towards the right after the collision. But this negative sign signifies that our assumption was wrong. Q will actually be moving towards the left after the collision, and its velocity will be 0.7 meters per second. So, but this is not what they want. They don't want the velocity. They're not concerned with the direction of Q. They just want the speed. So we know how to convert the velocity into speed. Speed is simply the magnitude of the velocity. So our velocity is minus 0.7. So the speed of the velocity modulus is 0.7 meter per second. This is your answer. Don't put minus 0.7 as the speed. Speed can never be negative because speed is a scalar quantity. So speed is 0.7 meter per second. Part B, state whether or not the direction of motion of Q is changed by the collision. Okay. So now we know that Q has a direction, a left direction after the collision. Before the collision, Q had a direction of left as well. So the direction of Q has not changed due to the collision. Calculate the magnitude of the impulse exerted by Q on P given the units of your answer. So we want to calculate the moment. This was part A. We have just verbally solved part B. For part C, we have to find the impulse exerted on P. So since we want to find the impulse exerted on P, therefore we have to use the mass of P, the initial velocity of P, the final velocity of P. The mass of P is 1.5. The initial velocity of P was positive 3. The final velocity of P was minus 2.5. From there we can find the impulse. Okay. Impulse is equal to m v minus u. V minus m, we have just taken the m common. So m is 1.5, our v is minus 2.5, minus our u was positive 3. So from there, our impulse is 8.25, negative 8.25. Impulse is also a vector quantity. This negative sign signifies that the impulse, the push on P was towards the left because of this negative sign. Negative sign means left in my math because I have taken the positive sign as the right direction as positive. Therefore, the impulse has a magnitude of 8.25. The impulse has a magnitude of 8.25. This is what your question asks. So this is our answer. One extra thing, if you want to say that the direction of this impulse is towards the left. although this is not what is asked in the question. Your answer is the magnitude of impulse will be 8.25, and don't forget to put the unit upon second. If you found this video useful, please subscribe. This really encourages me to make further videos for you guys, and press the bell icon to be notified when I upload a new video for you. Thank you very much for watching.